Hey guys, how's it going? So today we're gonna explore something in calculus called the derivative. And the derivative is an instant rate of change by definition. So basically, it looks something like this. So let's say we had a function. And then I'm gonna label my x and my y. This is f of x. A point here would be an instant rate of change, or a tangent line, if you will. And the derivative f prime x is equal to m, or the slope of the tangent line. And this is different from a secant line. A secant line looks something like this. I'm going to write S here for secant line, where there's a rate of change across a certain interval of time. But like in applications for the derivative, think of physics, think of velocity. The secant line, the average velocity would be the velocity, the total distance divided displacement divided by the total time. The tangent line would be the instantaneous velocity, or the velocity at a given second. It would essentially be the fuel gauge, the speedometer, what your speedometer would show on your car, basically. The definition of a derivative is this: lim h is some number, h tends to 0, and then f of x plus h over minus f of x all over h. That's the way it's calculated. And we're going to see some applications of this really quickly. So for example, f of x is like, so imagine this curve that I just drew. And then h would essentially be really close to 0. And then so like maybe h could be 0.01, 0.02. It's like just a very small incremental change along the x-axis. What is that? So then I'm going to erase this. So let's say f of x is equal to x cubed. What's x prime x? F prime x is this. Limit h tends to 0. F of x plus h minus f of x all over h. And x plus h cubed minus x cubed over h is equal to Okay, so x plus, we need to expand this because right now it's still 0/0, because if you were to, this would be x cubed minus x cubed, right? So it's still 0 divided by 0. You can't directly put the limit in yet. X cubed x squared h plus h. These cancel out. You can factor out an h here too. So 3x squared because h divided by h is 1 plus 3x h plus h squared. And then apply h, that's times 0 times 0. That's just 3x squared. So the derivative f prime x is 3x squared. So f prime 2 would be 12. Because 3 times 2 squared is 12. What if f of x was equal to the square root of x? What's f prime x then? Still using this solution. I'll just directly apply it here. I don't want to write it every time. Minus the square root of x all over h. And how do we break this part? We make it better by, here, I'll show you how. But multiply, and I don't know what the term is, but you plus here. Like I think it's the conjugate or something. And as you can see, because we did it that way, that's just x plus h. And that's just minus x. Multiply out the top. So it's clear you're left with an h there. H. Okay, and then that's lim h tends to 0. And let's see, h over h this obviously cancels out. And now we can directly apply the h into the limit. Root and then because this is 0, that's just 1 over 2 root x. And that's the derivative. And here's one more. What if f of x equals 1 over x? And f prime x is equal to lim h tends to 0. F of x plus h would just be 1 over x plus h minus 1 over x over h. And that's equal to, so here's the way we're going to do it. Because if you directly apply h right now, you get 0 over 0, which is not good. Sorry for that line there. I don't know why I drew that. 1 over x plus h, then times x over x. So you have the lowest common factor on both ways, and you can subtract the numerator directly. Minus 1 over x plus h over x plus h. All over h. And over lim h tends to 0. X over x times x plus h. Minus x plus h. Over x times x plus h. All over h. And then x minus h, that's negative h on the top. We can remove this stuff to the bottom. Over x plus h. I forgot the lim h tend to 0. So sorry about that. Can't directly apply this yet, but to get rid of this, we can. Lim h tend to 0. Negative 1 over x plus Well, I already said h is 0. So that's -1/2x. There you go. So whenever we have a need to find the derivative, we use the definition of the derivative, which is this. And then you try to do whatever you can to make it not 0 divided by 0. It could be expanding the numerator, as we did with the polynomial x cubed. It could be determining the conjugate, which we did with the root x. And it could be factoring out into getting the least common denominator. So do whatever you can to make it not 0/0 and directly plug the h in, and you're good to go. For now, I got to jump. I'll see you guys on the other side of the bridge. Catch you next time.